GCSE Physics. This video is about specific heat capacity. Different materials have different specific heat capacities. More energy needs to be transferred to the thermal energy stores of some materials to increase their temperature than others. For example, you need 4,200 joules to warm 1 kilogram of water by 1 degree Celsius, but only 139 joules to warm 1 kilogram of mercury by 1 degree Celsius. Materials that need to gain lots of thermal energy in their thermal energy stores to warm up also transfer loads of energy when cooling down. They can store a lot of energy. Specific heat capacity is the amount of energy needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. Here is the equation that links energy transferred to specific heat capacity. Change in thermal energy equals mass times specific heat capacity times temperature change. You can investigate specific heat capacities. To investigate a solid material, for example copper, you'll need a block of the material with 2 holes in it for the heater and thermometer to go into. You can see this below. You can investigate specific heat capacities. Measure the mass of the block, then wrap it in an insulating layer, for example a thick layer of newspaper, to reduce the energy transferred from the block to the surroundings. Insert the thermometer and heater as shown in the picture from the previous slide. Measure the initial temperature of the block and set the potential difference, V, of the power supply to be 10 volts. Turn off the power supply and start a stopwatch. When you turn on the power, the current in the circuit, i.e. the moving charges, does work on the heater, transferring energy electrically from the power supply by heating, causing the material's temperature to increase. As the block heats up, take readings of the temperature and current, one every minute for 10 minutes. You should find that the current through the circuit doesn't change as the block heats up. When you've collected enough readings, 10 should do it. Turn off the power supply using your measurement of the current and the potential difference of the power supply. You can calculate the power supply to the heater using P equals VI. You can use this to calculate how much energy E has been transferred to the heater at the time of each temperature reading, using the formula EPT, where T is the time in seconds since the experiment began. If you assume all the energy supplied to the heater has been transferred to the block, you can plot a graph of energy transferred to the thermal energy store of the block against temperature. It should look something like this image below. Find the gradient of the straight part of the graph, temperature change divided by change in thermal energy. The specific heat capacity of the material of the block is 1 divided by gradient times mass of the block. You can repeat the experiment with different materials to see how their specific heat capacities compare. I hope this video helped you. Thank you for watching. Please don't forget to subscribe and like the video.